I'm gonna call me Luther. Can you be my tutor? I'm about to feel like tutor. Can you be my tutor? I'm about to feel.
Hello everyone, I hope you're all doing great. This is your favorite tutor. In today's lesson, we are going to be proving whether a function is one-to-one or not. But before we can get to the point of proving whether a function is one-to-one or not, we first have to define what a one-to-one function is. A function is said to be one-to-one when each x value in the domain is mapped to one and only one y value in the range. Let's take a look at the arrow diagram at the bottom here. We have the set x here, which represents the domain, and in the domain, we have x values. That means A is an x value, B is an x value, C is an x value. These x values are also known as inputs. That means that A is an input, B is an input, and C is an input. On the other hand, we have the set y. The set y represents the range. In the range, we have y values. That means that 1 is a y value, 2 is a y value, and 3 is a y value. Y values are also known as outputs. That means that 1 is an output, 2 is an output, 3 is an output. Now, what a one-to-one function simply does is that it maps one input in the domain to exactly one output in the range. As we can see here, we have A in the domain mapped to exactly one output, which is 1. We have B in the domain mapped to exactly one output, 2 in the range. We also have the input C in the domain mapped to exactly one output, 3 in the range. So this basically is a one-to-one function. In this lesson, we want to prove that a function is one-to-one by showing that two different inputs cannot be mapped to the exact same output. What do we mean by this? We want to show that the input A and the input B cannot be mapped to the exact same output, 1 in the range. In other words, we want to ensure that whatever is going on in this arrow diagram here to the left does not happen. So we do not want this to happen. Instead, we want to see exactly one input in the domain mapped to a unique output in the range. So this is what we want to see happen. So what we are trying to say in short is that two different x values should not share the same y value, or two different inputs should not share the same output. This is what we're trying to come across. Now, in order for us to prove that a function is one-to-one, we use the one-to-one algebraic test to prove that the function is one-to-one. So what then is the one-to-one algebraic test? Well, this is a test that assumes that the only way a function can produce two identical outputs and still be a one-to-one function is if the first input A and the second input B are identical as well. So what does this definition mean? Well, the one-to-one algebraic test first starts by assuming that a function is producing two identical outputs. That is, the function is producing the output f of A is equals to 2 and another output f of B is equals to 2. So it starts first by assuming that a function is producing two identical outputs, or outputs that are equal to each other. This means that f of A is equals to f of B. Then it goes on to further assume that the only way this function that is producing two equal outputs can still be one-to-one is if the first input A and the second input B are equal to each other. So it assumes that the only way this function that is producing two equal outputs can still be one-to-one is if A and the input B are equal to each other. So this is the condition that we have here. So why then does it make this assumption to say, look, if you are a function, you are producing two outputs that are equal to each other, the only way I can agree that you are a one-to-one function is if your first input A and your second input B are equal to each other. Why does the test give this condition? Well, if we start first by looking at the output, we can see that the output f of A is equal to the output f of B. When two things are equal to each other, they have become one thing. Therefore, f of A equals f of B means that this is one output because they're equal to each other. They're both equal to 2. Therefore, they've become one output. Now, let's go down to the inputs. Why should the inputs be equal to each other as well? We know that when two things are equal to each other, they are basically one thing. Therefore, these two inputs, they have become one input instead of 2. So now we have a situation where we have one input as a result of the inputs being equal to each other, and we also have one output as a result of the outputs being equal to each other. What does this mean when we look at an arrow diagram? Let's draw one here. So we have our domain here where a is equals to b. We've agreed that a equals to b is basically one input. Let's draw the range where we have our outputs. So f of a is equals to f of b. And because f of a is equals to f of b, we've agreed that this is basically one output. So we have our range here and we have our domain here. So because we have exactly one input in the range and we also have exactly one output in the domain, we can easily map this one input in the domain to exactly this one output in the range. So therefore, we can now draw our arrow. We have mapped the input in the domain to the output in the range. And when we look at this condition or this situation that we have here, we have satisfied the condition of a one-to-one function. A one-to-one function maps exactly one input in the domain to exactly one output in the range. This is why our test first starts by assuming to say, look, if you are a function and you are producing two identical outputs or outputs that are equal to each other, the only way you can be a one-to-one function is if your first input A and your second input B are also equal to each other. Therefore, you create a situation where you can map one input in the domain to exactly one output in the range. When you have this scenario going on, you have basically proved that the function is one-to-one. So this is the whole purpose of the test, to ensure that we have one input mapped to exactly one output. So here's the general rule. Given two different inputs, A and B, a function is said to be one-to-one if two identical outputs, f of A equals f of B, also means that the input A is equals to the input B. However, if the two inputs A and B are not equal to each other, then the function is not one-to-one. Therefore, when proving that a function is one-to-one, our goal is to show that A is equals to B, assuming we have two identical outputs. And if we look at the arrow diagram here below, it highlights the importance of showing that A is equals to B when proving that a function producing two identical outputs is one-to-one. When we show that A is equals to B, it means that we have one input in the domain. And because our two outputs are equal to each other, it means that they are also one output. Therefore, it becomes easy for us to map exactly one input in the domain to exactly one output in the range, hence proving that this function is one-to-one. And if we like, we can actually assume that A is equals to 1. And because A is equals to B, that means that B is also equals to 1. Since both A and B are equal to 1, we can see that we actually have one input in the domain, and this input is the number 1. So in the domain, we actually have the number 1, and because our two outputs are equal to each other, they are one output, and this output is 2. So we have the number 2 in the range, or we have the output 2 in the range, and we can easily map the input 1 to exactly one output in the range, which is 2 in this case, therefore making our function one-to-one. So this arrow diagram at the bottom is the same as the arrow diagram here at the top. And this is why it's important for us to show that A is equals to B when proving that a function producing two identical outputs is one-to-one. Why? It gives us the possibility of showing that we actually have one input in the domain, and because the two outputs are also equal to each other, we actually have one output in the range, therefore making it possible for us to map exactly one input in the domain to exactly one output in the range. Now, let's get a little bit more practical by solving some tutorial sheet questions. If you would like to sign up for our math tuition classes, please feel free to do so using the link in the description below. So, we are going to be solving question 1a from tutorial sheet 3, 2024 Math 1110. The question here reads, check whether the function given below is one-to-one. We are basically being asked to check whether these four functions over here are one-to-one. So, we're going to begin with Roman numeral 1, which is f of x is equals to 3x minus 5. Now, remember that when using the algebraic test to prove that the function is one-to-one, the first thing that we do is to assume that the function is producing two identical outputs, or rather, we assume that f of a is equals to f of b, because when f of a is equals to f of b, it means that a function is producing two identical outputs. In the same way, we are going to assume that f of x equals 3x minus 5 is producing two identical outputs. Now, to do that, we are going to say f of a is equals to 3a minus 5. We're basically just substituting f for x. We're also going to say f of b is equals to 3b minus 5. So now that we have f of a and f of b, we are going to assume that f of a is equals to f of b. To assume f of a is equals to f of b, we are going to equate the output f of a, which is 3a minus 5, to the output f of b, which is 3b minus 5. And just by doing this, we have assumed that f of a is equals to f of b. Now, the second step that we are going to take to prove that a function is one-to-one using the algebraic test is to solve and simplify this equation. And the hint here is to solve for a, or rather to make a the subject of the formula. When solving and simplifying this equation, why do we need to make a the subject of the formula? Remember that the goal we are trying to achieve when proving a function is one-to-one is to show that a is equals to b. So when we make a the subject of the formula, we are constantly reminding ourselves that we need to simplify this equation until we get to the point where a is equals to b. If a is equals to b, it is a one-to-one function. If a is not equals to b, it is not a one-to-one function. So let's solve and simplify this equation. We are going to have 3a here minus 5 is equals to 3b minus 5. Now the first thing that we need to do is to get rid of negative 5 on both sides. To do that, we are going to add 5 on both sides. So we're going to have 3a minus 5 plus 5 is equals to 3b minus 5 plus 5. The 5's cancel each other out, therefore we're going to be left with 3a is equals to 3b. Now, to simplify this further, we need to divide both sides by 3. So we're going to have 3a divided by 3 is equals to 3b divided by 3. The 3's cancel each other out so that we just remain with a is equals to b. So we can see here that the simplified version of our equation is a is equals to b. Therefore, we have proved that our function is one-to-one. So the last thing that we just have to do here is to conclude in writing that our function is one-to-one. So we're going to say, therefore, f of x equals to 3x minus 5 is 1-to-1. And just like this, ladies and gentlemen, we have proved that the function f of x is equals to 3x minus 5 is 1-to-1. So now let's move on to the next question. The next question is Roman numeral 2, which is f of x is equals to x squared. And just like we did in the first question, we are going to assume that f of a is equals to f of b. This simply just means that we are assuming that the function f of x is equals to x squared is producing two identical outputs. Now, let's actually show that this function is producing two identical outputs. To do that, we are going to say f of a is equals to a squared. We're just substituting a for x. And then we're also going to say f of b is equals to b squared. We're simply just substituting b for x. Now that we have our f of a and our f of b, we are going to assume that f of a is equals to f of b. To do this, we're going to equate the output f of a, which is a squared, to the output f of b, which is b squared. Now we have our equation here, and the next step after this is to solve and simplify this equation by solving for a. To solve for a, what we are going to do is take the square root of a squared on this side, and then we're also going to take the square root of b squared on this other side. So we're going to have the square root of a squared is equals to the square root of b squared. Now let's simplify this further. The square root of a squared is a, and the square root of b squared is positive or negative b. So this is our final answer. But when we look at our final answer here, we can see that there is actually a problem here. What we are looking for is a scenario where a is only equal to b. But in this case, we can see that a is equal to positive b or negative b. This function is not a one-to-one function. So we can go on further to make our conclusion. We are going to conclude by saying, since a could be equal to b or negative b, our function fails the one-to-one test, because this shows that the function can produce the exact same output with two different inputs. For example, let's assume that a is equals to 2. So if a is equals to 2, and we know that a can equal negative b as well. So that means that in this case, negative b would be equal to negative 2. And then now let's get our function f of a, which is equals to 2 squared in this case. And then we also get our function f of negative b, which is equals to negative 2 squared. When we come to the first one here, f of a is equals to 2 squared, we know that 2 squared is simply just 2 times 2. So we're going to have 4 as our final answer because 2 times 2 is 4. But then the interesting part is that when we come to negative 2 squared, we know that when we multiply two negative numbers, the negatives cancel each other out, leaving us with a positive number. Therefore, negative 2 times negative 2 is equals to positive 4. So this is our final answer. This shows that this function is not one-to-one because it has two different inputs mapping to the exact same output. This is not a one-to-one function. Instead, it is a many-to-one function. Therefore, we can conclude that since a could be equal to b or negative b, our function fails the one-to-one test because this shows that the function can produce the exact same output with two different inputs, and hence the example that we have shown here. We have managed to check that the function f of x is equals to x squared is not a one-to-one function. Instead, it is a many-to-one function. So now let's move on to the next question. Our next question is Roman numeral 3, which is f of x is equals to x cubed. And just like we did with our previous two questions, we are going to assume that this function is producing two identical outputs, or we're going to assume that f of a is equals to f of b. Now, to do this, we're going to say f of a is equals to a cubed, and we're also going to say f of b is equals to b cubed. To assume that f of a is equals to f of b, we are going to equate the output f of a, which is a cubed, to the output f of b, which is b cubed. So now we have our equation. Let's simplify this equation by solving for a. To simplify this equation by solving for a, we are going to take the cube root of a cubed and the cube root of b cubed. So we're going to have the cube root of a cubed equals to the cube root of b cubed. Let's simplify this further. The cube root of a cubed is simply just a, and the cube root of b cubed is b. We can see that our simplified equation is a is equals to b, and because a is equals to b, we know that this function f of x is equals to x cubed is one-to-one. So we're going to conclude by saying, therefore, f of x equals to x cubed is one-to-one. Now we can move on to the next question. If you would like to sign up for our math tuition classes, please feel free to do so using the link in the description below. Our last and final question is Roman numeral 4, which is f of x is equals to 1 over x. And just like we have done with the previous three questions, we are going to assume that f of a is equals to f of b, which just means that we are assuming that this function is producing two identical outputs. The next thing that we are going to do is say f of a is equals to 1 over a, and then we're also going to say f of b is equals to 1 over b. Then now we are going to assume that f of a is equals to f of b. To do that, we are going to equate the output f of a, which is 1 over a, with the output f of b, which is 1 over b. So now we need to simplify this by solving for a. To do that, we are going to multiply both sides of the equation by both a and b. So it's going to look something like this. We're going to have 1 over a times b, and then we're going to have 1 over b on the other side times b times a. So this is just one and the same thing. We're just interchanging them. And then if we look at our equation now, we can see that we can cancel out a here with that a, so that when we multiply 1 times b, we just have b here. And then on the other side, we can see that we can cancel out b here with b, so that when we multiply 1 times a, we remain with a. In this case, we can see that we have b is equals to a, which is just the same as saying a is equals to b. These two can be interchanged because they mean one and the same thing. b equals to a is just the same as a is equals to b. So when we look at our simplified equation, we can see that our function f of x is equals to 1 over x is 1-to-1. Therefore, we're going to conclude by saying, therefore, f of x equals 1 over x is 1-to-1. And just like this, we have proved that the function f of x is equals to 1 over x is 1-to-1. Ladies and gentlemen, we have come to the end of this lesson. This is how we can prove that a function is 1-to-1. All we have to do is start by first assuming that a function is producing two identical outputs. Then after that, we move on to solving and simplifying the equation. If we find that our simplified result is a equals to b, then we know that our function is 1-to-1. However, if a is not equals to b, then we know that the function is not 1-to-1. This is how we can solve such questions. If you would like to sign up for our math tuition classes, please feel free to do so using the link in the description below. Thank you very much, and see you in the next lesson.